Thank you all for joining us. This is our last talk of the Simeode conference, so excited for this. It's my pleasure to introduce Marcelo Guerra Hahn, presenting on enhancing differential equation modeling with large language models.
Awesome, thank you. Thanks everybody for surviving all the way. I'm happy that I live in the West Coast, so it's only 2 p.m. here, but I think there is people from all the time zones. So as the slide presents, I wanted to discuss a little bit using LLMs to solve differential equations. And the first thing that I always introduce is this idea that every generation is kind of dealing with the next level of technologies. So at the very beginning, you had to solve differential equations by hand. Then you got some tools. Then you got more tools. Eventually, we got computers. And now the computers can help us a little more. So when you think about using LLMs or any other technology, Python or anything else, you can always imagine the person coming from the past trying to complain that somehow you are cheating or using something that they didn't have available. So if you lived in a century where you had to do this with some version of a pen, then now the computer will look like cheating. And if you spend your whole life learning how to do that by hand, and now it turns out that a calculator or a computer can do it in a second, then that appears problematic. And that is happening to us right now. It happened to us already when Python and those things became popular, but it's happening to us again, which means we're in a scenario where we may have to lift what we're expecting people to do and learn one more level, again, the same way that we lifted it from when I studied differential equations and I had to do it in a piece of paper, to then doing it in the computer, and now to use some more technology to evolve with that. So it is always fun, and I do computer science and technology, so it is always fun to be at the edge, but it's also very scary because now whatever I was doing before becomes a little irrelevant and I have to jump to the next thing. So how do LLMs play in here? When solving differential equations, we have a couple of problems. The first one is that the math is very complicated. So we usually don't say 2 plus 2 equals 4. We don't have the differential equation equivalent of 2 plus 2 equals 4. So when we try to explain math, we usually don't use differential equations as the first thing. Actually, when I was in school, we used to use differential equations as a way to scare people away. Be like, oh, I know how to solve that complicated equation. And that was kind of the limit of how math was complicated. So the calculations and the reasoning here is complex. The calculations that we have to do, even if you do them by hand, especially, if you do it by hand, they're going to take a lot of time. So if you remember from the homeworks or the problems that you solve when you study this, or even looking at the students solving them now, it takes a long time. It's a lot of writing and moving numbers around and moving letters around. So it's pretty time consuming and fairly tedious. And then if you want to do this with a computer, this is also not the hello world of computer science. So even if you wanted to use computers, it's still pretty complex to try to figure out what exactly to write to the computer in order to get the computer to help you. And then interpreting the results is also not trivial. So even after I spend all this time in the paper or in Python, I found the answer finally. And then how do I interpret that? That's a whole other thing. So overall, then, dealing with differential equations takes a long time in each step. And that is why every time we have a computational advance, we actually should be slightly happier because we can move on to the next more interesting thing. So then LLMs participate in all parts of solving these problems. So particularly, we can get the LLM to help us with the steps. It can also help us in part with the computation. It can tell us what the computation is doing. It can do the charts for us, and it can make dealing with this a little simpler. It can also give us code, so it basically can complement every part of what we are doing here. So let's go with this. Let's do the canonical example so that we don't have to overcomplicate the scenario. So we're just going to study the typical problem of population growth. So we have 1,000 people growing at 5% per year. The growth rate is proportional to the population. So more people, faster growth. And we want to formulate the differential equation and solve it to predict what is going to happen in 10 years. again, this is kind of the early page in the book problem to try to address. And so let's be very transparent. So one very scary scenario, and this is something that we still haven't figured out exactly how to deal with, and I will talk about this a little more at the end, is that I just take my LLM and take the text from the slide and then paste it here and just say, hey, solve this. And the LLM will have no issue with giving me the straight answer. And this is a problem. And yes, there are students doing this. And it's a problem that I still don't have a good answer to. I'll tell you more or less what I'm doing again towards the end, so we don't move the presentation towards this particular scenario. But it is definitely true that the LLM can totally spoil the question. And we have to find ways to moderate that, but that is totally true. So a student could just go and say, hey, do the homework for me, and then I come back and use it, and come back and use it. If I don't do that, then I can actually do something smarter, which is I try to learn how this works. So instead of telling the LLM to solve the problem for me, I'm going to ask the LLM to work on this with me. So I'm going to frame the problem as you're going to work with me on this. And you can see that the LLM is already very aggressive. So the LLM is designed to help you solve the problem as fast as possible. So right now we stopped a little earlier because it didn't solve the whole thing, but it was still fairly aggressive. So I still have to deal with this and try to prompt it a little more. So I'm going to say something like, don't solve the problem. Let me think about the variables that are involved. Is rate a variable? And you can see that it is giving me more context on what I'm trying to do. So the goal here, then again, is to use the LLM more as my tutor as compared to as the calculator that will just give me the answer. So what I have to be able to get used to is to start framing the prompts in a way that I don't have the answer from the LLM. Now, it is possible that at a certain spot I want the answer or I want to get faster, so I can moderate it that way too. But overall, I want the experience to be similar to the tutoring experience or the TA experience, depending on what you're doing. Now, for those of you who are like, this spoils too much the thing, it is true, but if you ever see that a tutoring session, you're also going to see that eventually the tutors also tend to spoil the answer because we have to move on and get to the next student. So you can observe that the behavior of the LLM is a little aggressive, but it is still within the margins of being usable. So once I have this, okay. So once I have an idea of what I'm doing, I'm gonna go back to the problem, and I'm gonna say, I'm thinking of dp dt equals r as the equation. What do you think? And you can see that I was wrong. So it's going to tell me, no, that's not a thing. Instead, you want to do this, and here is why. And so I can read the whole thing, or I can just keep prompting, and I can say, what is K here? And you can see that it is continuing to explain what I'm doing in this fashion. So again, the idea here is to try to use this as the tutor or the lesson, and not so much as the finder of the answer. So now that I have the equation, which is going to be this, So I tried to identify the variables, and then I got my equation. So I took that. So now we want to use the equation. We want to solve the equation. So then I have to get the LLM to try to help me understand what the answer to the equation is. So I'm thinking to solve dp dt equals kp by integrating on both sides. And the LLM is going to give me an idea of what I'm doing. And it is saying, okay, this seems like a reasonable idea. And here are all the steps. Okay, so now again, this may be depending on where I am in the course. This may be a good idea or a bad idea that is so specific. So let's say, well, let's slow down. Explain step one more. And then you can see that it's going to give me a longer explanation as to what it is that I am supposed to be doing. And I can keep doing it this way until I understand what I did or understand what the LLM is telling me, and then I can try to do it by myself. So eventually then we can keep going. So go to the next step. And you can see that it shows me all the steps. Now, in the past, before we had LLMs, this was done by the book, the video, the professor, or whatever other tool I was using to address the problem. Now it's just giving me the steps one at a time. And then I can predict the actual answer. And now I can do this by hand in a calculator. I can just get the computer to do it. So we're going to say find the answer. And then it's going to try to give me the answer. This part is actually the more complicated one for the calculator because this is just trying to do math. And so that is more or less what the thing is predicting. We'll talk about that in a second. It is perfectly possible that this is totally wrong, so we have to address that in a minute. But for now, we will assume that this is fine. And so I use the LLM then to help me navigate through the procedure. This is the same as at the beginning when he gave me the answer, but now I did it slower, so I was trying to understand the steps. So then after I have the solution, I can actually do things that are more advanced and that will be very time-consuming to do by hand. So for example, I can say plot the solution. And here we are back to the issue of whether this should be something that I know how to do or not. If I wanted to do this for real, I would have to, again, use pen and paper, or I can write some Python code, or I can write some Excel sheets. So it will be very depending on my skill set, whether I can do this or not. But whatever the answer is, it's not going to be this fast. So you can see that the LLM can produce these fairly complex charts in a second. And so that is a solution to plotting over time. So that's how I see it. And now I can explore what happens if I change the growth rate. So now I'm going to come here and say plot, add the lines for rates. Let's find what the original rate was. 10% above and below the current one. And eventually, this is going to produce the chart, which again, it takes a minute, but it's substantially less than it would have taken for me to do this totally by hand. And I may have reached the limit. No, here we go. Okay. And so here we can see the effect. And here you can see the line with the difference in growth for the different rates. And again, something that I can definitely do by hand that would have taken me substantially more time to do if I wanted to do that. And then I can also change the initial population, or I can make the model slightly more advanced. So then here is the potential of the LLM. The first idea is that I can get step-by-step guidance when I'm solving my equations. So instead, again, I could get the solution, but instead of that, I could get the LLM to give me one thing at a time of what I'm supposed to do. And that is more or less my interaction with the book or the video or whatever other content I am using to try to learn. It can help the student spend more time on the actual usage of the thing instead of the how to calculate it. So instead of spending like an hour doing all the math and then coming back and finally being able to interpret it, now I can solve problems that are interpretation problems much cleaner. So once I know how to do it, then I don't have to keep doing it. I can just have the computer help me with that. And then it helps with this interaction. So again, instead of me having to go and do something, I can ask the computer, look at the chart, explore the chart, and with the computer back and forth. And then I can also use this to adapt to different levels. So for some students, the LLM, the first solution was okay, and they can understand it. So that is perfectly fine. For other students, they need the more slow-paced thing that I was showing you. And for other students, they need some in-between. So then compared to a class where you are teaching in a particular way, and that covers the distribution somehow. Here, the LLM can go really slow for somebody who needs more help, and really fast for somebody that already has context. And so that is a important idea there. And then there are some limitations. The first one is that the thing could be totally wrong. So there is no guarantee that what the LLM produces is actually correct. So in a way, you have to have enough understanding to know what is happening and whether that is reasonably approximating the solution. So that does cause a problem. And in many cases, a student ends up producing results or learning the wrong thing. So we still have to monitor this correctly to make sure the outcomes and what is happening is correct. What the LLM does depends a lot on what you type. So again, as I showed you at the beginning, if I type solve the problem, the LLM will solve the problem. So that ruins the experience. So we have to start getting used to the idea of I'm going to interact with the LLM similar to what I will interact with a professor, where I don't go to the professor and I'm like, hey, what is the answer to the problem? I start asking questions that help me move forward. There are some technologies where you can train the LLM itself to behave like a professor. So if somebody comes to you and asks you for the answer, you are like, no, I can't give you the answer, but we can work on the problem. So there are some technologies in there. It's not easy enough for people to do it by themselves in general. So that is not something that I would recommend at this early stage. But eventually we will have an LLM that will behave like a teacher, and again, will avoid spoiling the question or doing things that will cause problems. The LLMs are still not particularly good at math. So in this example, we did fine, but in general, when you start giving complex math problems to the LLM, it may not work well, which in here, it plays both ways, because you can use that as a way to force the students to learn so they don't take whatever the LLM is saying as a truth, but it also may complicate the learning there. So in general, we still need oversight and helping interpret. So it's not something that we can just send the student play around with this and keep going. Okay, so the biggest problem we still face, though, is academic integrity. So I've been using technologies like this for a while, and here are my 3 ideas on how to deal with this. Idea number 1, which is something that we have done for a long time already, is that we usually in homeworks don't accept the answers themselves. We usually ask people to show the steps. So here we can also ask them to show the steps. The trick here compared to the other one, or the calculator, is that the LLM can also produce the steps. So now we have an issue with, did they produce the steps or not? My favorite mechanism to deal with this is to actually talk to the students. So a long time ago, before paper and grading multiple choice and things like that were so popular, we used to, or people used to test students by talking to them. And we moved to the whole bureaucracy of the paper thing because it was more practical. But sadly, that's not going to work in the future because the technologies will be able to do that without a problem. So in multiple classes, I had to revert to just asking the students. And this can be very problematic. Some students are not very excited about this. And some of these conversations are very problematic because people don't understand the dynamic of, well, I try to use it for help and things like that. But as long as the bar is you need to be able to explain what you wrote or whatever you got help for, but it's written, then you will be fine. But if there is a step in here that you cannot explain, then that is the same as plagiarism. Like you just took something that you got found somewhere and put it there. So that is the idea. The big problem with this is that it doesn't scale very well because the current system is more or less implemented for large scale grading by using paper and machine. So we'll have to find a way for that. And in classes that are a little big, we already did this in other ways. So sometimes we do homeworks where we randomly grade homework problems because we don't have enough time to grade them all. So we just grade like some random sampling of the homework. So this is similar. So you can do some random sampling of the students and be like, okay, there is this audit mechanism. And so X amount of students have to show their work to make sure there is no LLM involvement that is excessive. And that seems to be fine. I did have a good time talking to the students. So that has been quite fun, but it is, again, hard to scale if you're teaching to hundreds of people. But I'm not visualizing a way or not imagining a way in which we can stay with this mechanism of bureaucracy grading that will be sustainable in the long run. Because for every time we invent a system to preempt the machine from solving the problem, the machine is going to catch up. So there isn't an easy way, and we need to find a way through that. Okay, and so those are my insights on using LLMs for this. So what I wanted to leave the last 5 or 6 minutes was for people to ask any questions, share your experience, horror stories from grading LLM work, and things like that.